Before this, we had this. So, this may be a generational thing, but for some younger folk, this is what is called a newspaper. And this is where we used to get our information from. And not only did we get our information from it, but we also got our enjoyment from it. Who could not resist the Sunday morning comics? Well, for those individuals coming up in the world, it seems like nowadays that is the only source of information. But you have some of the folk like myself who still subscribe to newspapers. I enjoy the newspapers. It gives me an opportunity to exercise the gray matter that's between my ears. So the question is, for those who still subscribe to newspapers, what do you do with all this paper? Well, my wife has come up with a solution, and I kind of have to look sideways at her sometimes with the solution she came up with. But she often will make these things. If you don't know what these are, they are newspaper logs. They are newspapers that have been soaked in water with just a little bit of dish soap and rolled up and dried in the sun. And to her, she thinks that this is going to be a real valuable source of heat in the future if we have a power outage, if we go camping, or whatever the case will be. So it made me start wondering, how good are these things compared to the real thing? Well, yesterday I got bored, and when I get bored, I start thinking of really weird things. So I made some tests to determine how a newspaper log compares with the real thing. Making newspaper logs are fairly easy. You need a basin or a sink, and you want to fill it with warm water. So once you have your basin or your sink filled with water, and this procedure, this formula comes to us from Bob Vila, a very well-known TV personality. So you have your warm water, and you add about a teaspoon of dish soap. And to that, you put your newspaper. And according to Bob, you want to soak your newspaper for at least 1 hour, but no longer than 18 hours, because after 18 hours, the newspapers will decompose so much that it will just turn into mush, and you really can't do much with them. So we're going to let them soak for a while and come back. Okay, these have had a good soaking, and I probably have about 2 inches worth of newspaper here, but you can do, you know, my basin here is probably 10 inches deep. You can do a whole bunch of newspapers. But anyway, after you do the newspapers, you want to take them out and let them drain a bit. Now the newspaper logs my wife made are about 12 inches by 1.5 inches in diameter. I'm not sure exactly why she chose this particular size, but it seemed to do her fine. So we now have our newspaper. Now this point can get a little bit messy because we're dealing with mush, basically. Now, in Bob Vila's article, what he will often do is he puts a piece of dowel wood to wrap the newspapers up on. Well, I don't have a piece of dowel wood, so I'm just going to roll them up by themselves. And he says you want to take 1 or 2 sections of newspaper, but I'm not sure exactly what a section is defined. Is a section the sports section and the movie section, or whatever it may be? So I'm just going to take a chunk of newspaper, and I'm just going to take one end, and I'm just going to start rolling it nice and tight. and I'm kind of squishing the water out as I go. So there's my piece of newspaper log, and this is my Y. So they're about the same size, and this is about one section of newspaper. So I suppose, I'm not sure if size matters, but I could probably make these as small as I want to or as big as I want to. Here's a piece that's even larger, and here's some kind of stuff that's already fallen by the wayside. Okay, so this is a much bigger log, so several times larger. So after you have your logs like this, you set them outside in the sun. It may take 2 to 3 days, but once they dry, that's your newspaper log. Now, back in the day when I was growing up, the Boy Scouts used to come by my house and pick up newspapers that they would gather up, and they'd sell them to companies that used to make insulation. Well, all the insulation I've seen lately is all fiberglass based insulation. I don't remember seeing the the insulation that was normally made out of newspapers. And newspapers have gone down in popularity lately. Everyone's turning to the internet, and so newspapers are not as popular as they once were. But for those who still take a newspaper, what do you do with the newspapers once you're done with them if all you can do is turn them into the recycling? But face it, when you recycle newspapers, unless there's a need out there for newspapers, they just end up going to the landfill, and nobody wants that. So this might be a good alternative to what to do with newspapers. Now, according to Bob Vila, these newspaper logs, when they are burned, they do create more ash, but they also create less smoke and emissions than regular firewood does. So you could say that these are green on 2 accounts. One, the newspaper is not going to the landfill, and 2, that burning these these burn with less emissions than a piece of firewood would. So that is a positive. To begin this little experiment, this is what I have. So I have a bowl of water here that probably has about 1.5 gallons of water. It's been sitting out here for several hours because I want the water to be at the same temperature as the air. So I want the water to be at the same ambient temperature as the air. So as we heat the water up, we have a true set point, and the surrounding air is not going to affect it. And then I have a number 10 can here that has a bunch of holes in it, and that's where we're going to put our fire in. I have a newspaper log right here. This is 124 grams. And then I have the bowl of water. We're going to put 1 pound of water in here. Straddling it, I have a digital gauge. I have some lighter fluid. And for this test, for all the tests we're going to do, we're going to put 1 tablespoon of lighter fluid spread evenly with the combustion material. Got some matches. So with all that being said, we're going to go ahead and start the test. So this is going to be my combustion chamber. It's not pretty. Has a bunch of 1/2-inch holes drilled into it. And we're going to take our newspaper log and we're going to cut it up into thirds. Because it won't fit inside. Put this down in here, arrange it on top of each other like that. Okay, so this is our 1 tablespoon of lighter fluid. I'm going to spread it evenly around on the newspaper logs. And I have 1 pound of water measured out. And according to this is 74.5 degrees Fahrenheit. And since I have a camera running, if I do set fire to my garage, I'll have video of it. No, I think I'm being fairly safe here. Okay, so we're going to go ahead and light that. And we will see how many degrees our newspaper log inside will raise the 1 pound of water. And just to let you know, we do have the can off the ground. Make sure we do have enough draft going in for the fire itself. Okay, so far we're at 126 degrees and climbing. We just passed the 15-minute mark, and it looked like we may have peaked at 15 minutes at 142 degrees, because on the 16-minute mark we're down to 141.8, so we're starting to decrease a little bit. At the 20-minute mark, we actually have gone up in temperature. We are at 146.1, still smoldering, no flame. So I'm here in my grove, and this grove is primarily scrub oak. They're small little oak trees that grow in the mountains here, and I just happen to have a stand of those here. And we're looking for some wood. So I'm going to use some oak wood. Now this is still kind of green. So I'm going to use some twigs and stuff I can find in my grove for firewood to compare it to the experiment I'm doing with the newspaper logs. Here's some twigs. And these are quite dry here. I'm going to grab some of these and compare it to the newspaper log. So I went into the grove of trees I have on my property, and I got 124 grams of scrub oak. This is all dried wood, and so this is exactly the same weight as our newspaper log. So an hour and a half later, we're at 113 degrees, well 113.9 degrees. So we're going to call an end of this experiment after 90 minutes. And we're going to move on to the real wood. So just for the fun of it, we're going to see how much water evaporated out from our original pound. And we have 0.698 pounds of water evaporated out, which is 317 grams. So the next thing we're going to do is we're going to go to the test with wood. So I have 124 grams of wood taken from my scrub oak trees. We're going to put that inside of here and see how this compares to the newspaper log. It may look like it's more, but it's the same weight as a newspaper log. And we have 1 tablespoon of lighter fluid like we did with the newspaper logs. We're going to put that in here. Our 1 pound of water is 75.2 degrees in temperature. And here we go. Okay, at 5 minutes we're at 129.9 degrees. 10 minutes we're 163.8. At 15 minutes, we're at 184.6. And the last reading at 90 minutes, 81.3. Okay, then we're going to see how much water loss we had. .678 pounds. Which is going to be the same as 308 grams. And there remains there's some chunks left here. It wasn't as much as the newspaper roll, but that's what remains. Take a look at the two graphs for the newspaper log on this side and the oak wood that was burned on this side. We can make a comparison how efficient the two different materials were. First, we're going to go ahead and put in the baselines of the temperature of the water for each test. For the oak wood, the baseline was 75.2 degrees, and for the newspaper logs, it was 74.5 degrees. And then we're going to add the temperature between the baseline and the maximum amount of the temperatures over time for the oak and then for the newspaper. If we take the area of the oak wood and remove it and lay it over the newspaper log, this will give us a bit of a comparison of the difference between the newspaper log here in red and the oak wood in green. We can see that the oak wood peaked early in our test, but then rapidly decreased, where the newspaper log did not peak as much as oak wood, but the duration was even greater. So the question begs, which is better, newspaper or oak wood? One thing to consider is the temperature in which food begins to cook. If food begins to cook at 145 degrees, then the oak wood has a better chance of cooking food than the newspaper log. The newspaper log barely gets into the 145 degree area, where the oak wood definitely gets into the 145 degree area. However, food-borne bacteria doesn't start to die until 165 degrees, which means that the newspaper log would never reach that temperature where the oak wood would. First of all, I probably need to come up with a bit of a disclaimer that I tried to perform this experiment as accurate as I possibly could. I am sure that there are other methods out there that could probably do a better job than what I did. But from my observations, I think I did a pretty decent job. So the first question is, which is better, a newspaper log or oak wood? Well, from my observations, this is what I found. Well, the total area of the newspaper log was a little bit larger than the total area of the oak wood. So that kind of leaned towards that maybe the newspaper log is a little bit better than oak wood. Well, on the other hand, the newspaper log was only able to evaporate and generate heat enough to evaporate 0.302 pounds of water, where the oak wood was able to evaporate a little bit more. So maybe oak wood would be a little bit better. Well, according to Balboa Pacific, who actually ran some more thorough tests, they came out with the results that wood can generate 8,600 BTUs of heat, where newspaper would only generate 7,975 BTUs of heat, which would lead that wood is better than newspaper. Well, according to Bob Vila, newspaper logs have less emissions than wood, and so maybe newspaper, which does lag a little bit behind oak wood on the BTUs, may generate less emissions. So maybe that is something to also think about. So for those who do have newspaper and you don't want to make newspaper logs, or don't have a fireplace, well, what do you do with your newspaper if you're not going to make newspaper logs? Well, here are some suggestions.